அவங்க எல்லாம் வராங்கன்ட்டு கண்டு போறதுலடி பெரியம்மே. ஒரு 2 தான் சோறு இல்லையா?
Mm. Good evening, everyone. On behalf of Department of Biomedical Engineering, SRM Institute of Science and Technology, I welcome you all to the 6-day faculty development program on harnessing artificial intelligence in healthcare excellence, innovations, insights, and impacts. It's my honor and privilege to introduce the speaker for today's session, Dr. Harrison Gurunathan, Integrated Researcher, Sister Research Center in Real-Time and Embedded Computing Systems, Portugal. He received his PhD in Electrical and Computer Engineering from University of Porto. He holds his master's degree in Very Large-Scale Integration System from SSN College of Engineering, Chennai, and Bachelor's of Engineering at SRM University, Ramapuram campus in Electronics and Communication Engineering. His area of research includes wireless sensor networks, robotics, Internet of Medical Things, and protocols. During his tenure as a PhD student, he was actively involved in the SafeCorp project that aims towards safety-related cooperating cyber-physical systems. He has several publications in reputed journals and conferences. Thank you for accepting our invitation, sir. I welcome you to take over the session now.
Thank you for the introduction, Dr. Indumati. So shall I share my screen?
Yes, sir.
Just a second. Sorry, there is some. So you guys see my screen right now?
Yeah, it's visible now.
Okay. Okay. Good evening, everyone. So let's start our presentation today. So I'm going to talk on a very general topic. So I've been coming to this set of seminars over the last 2-3 days. So my presentation today is going to be in a much more general setting, not very specific. So today we are going to delve into the idea of Internet of Medical Things and go through how it is revolutionizing healthcare through connectivity. Before going into the presentation, I would like to talk a few minutes about my institution, where I am from. I'm from SISTER, which is a research center in real-time and embedded computing systems. We are a research unit based off the School of Engineering. It's called ISEP, which is the Polytechnic Institute of Porto, in the north of Portugal. We are specialized in real-time embedded systems, and we provide key components in developing things like cyber physical systems and critical computing systems. So anything related to time, we are there, basically. So we are involved with big companies like Boeing, Airbus, with companies like car companies like BMW and things on. Real-time embedded systems. So we have relevance in multiple domains like aeronautic and aerospace industry, in railway intelligent transportation systems. So we work majorly towards autonomous vehicles, and also in things like smart intersections, intersection traffic protocols and things like that. We also enable communications and technologies towards enabling smart cities and Industry 4.0. My PhD is more towards Industry 4.0, towards enabling low rate communication for industrial networks. Apart from that, recently I also have some more introduction and some interest into medical and e-health and things like that. So this is basically my institution. Up towards the end of this presentation, I would like to talk about some opportunities in my institution so that you guys can have a look into it. So let's go into the agenda of our presentation. So I'm going to split into 8. First, I'm going to talk about IOMT in a basic scale to talk about its definition and what are their key components. Then we'll talk about the evolution of IOMT, how this word IOMT came into existence, what is the historical context towards it, and how the networked healthcare and its integration of IoT basically works there. And then we should look into the benefits, why we should go for IOMT, like what are the benefits of IOMT, like talking towards like the monitoring and also towards predictive analysis and how these things basically work. We will shortly go into talking about data. What is the usage of data? So we have the medical data and how it is being used and how it is analyzed. And I would like to give a small example of the usage of data here. And then this is the big section. We'll be talking about machine learning in IOMT. And in this one, I have spread it into 4 different machine learning techniques, in which we'll talk about CNN, RNN, SNN, and deep reinforcement learning. And then I would like to talk about some use cases of IOMT and then go into communication. What kind of communication technologies are used in enabling IOMT? And finally, let's talk with some discussions towards the end. Yeah. I'm hearing some sound. Is it everything okay? Hello? Is everything all right?
Yes, sir, it's fine. Please carry on.
So let's go to the definition of IOMT. So IOMT, or the Internet of Medical Things, refers to the network of connected medical devices, software applications, health systems, and services that communicate via internet to provide healthcare delivery. This is an interconnected ecosystem that will be connecting, analyzing, transmitting health data in real time to enable better diagnosis, treatment, and monitoring of patients. So this is the basic definition of IOMT. So while reading this definition, we have to look into key points of this definition. So these are the major key points. So we are going to talk about network, the medical devices, how the communication is happening in real time. Sorry, I'm hearing a lot of noise.
Saranya ma'am, kindly mute your call. It is disturbing the presentation. Saranya ma'am. Sorry for the disturbance. You can continue.
Yeah, I can wait. No problem.
Saranya ma'am, kindly mute your call.
Sir, now you can unmute and speak, sir.
Okay, sure. So I was giving the basic definition of IOMT. So these are the 4 major words I would like to discuss, also think about when we delve into the idea of IOMT. The network of IOMT, what are the medical devices involved in the enablement of IOMT, how the communication and the analysis would happen in real time, and how healthcare in a general perspective is being given out. So this is IOMT basically. Before going into IOMT, we have to look into the concept of IoT. IoT is nothing but Internet of Things. Internet of Things describes the network of physical object. So when I call object, it is nothing but things. These are embedded within the sensor, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. So this was the concept which was created almost 2 decades ago. So these devices will be ranging from ordinary household objects to sophisticated industrial tools and even medical devices. So with more than 7 billion devices, IoT devices that are connected today, experts are expecting to have over like 10 billion by 2025. Over the past few years, IoT has become one of the most important technologies. So if you remember, I see a lot of doctors in the participants. So if you remember a few years ago, it was called as wireless sensor networks. And then it was called as cyber physical systems. And then now it has evolved into IoT because we are connecting all these mechanisms through internet. So over this 21st century, I think it is one of the most important technologies, and we can connect every object from kitchen appliances, cars, thermostats, every object, even baby monitors to internet. So this is possible, and it is giving us a more seamless communication between people and things. So let's have an idea about what are the technologies enabling IoT. First thing would be low-cost sensors. So if you remember, in 1965, there was a guy called Gordon E. Moore. He was the founder of this law called as Moore's Law. He said that the number of transistors in the computer chips should double approximately for every 2 years, right? So when we had this always changing, for example, in 1965, it was just 1,000 transistors in a chip, and now it has evolved to around like 50 million, for example, in a small computer. So, and I'm sorry, there is again noise. Can you please? Okay. The thing is, like, even the cost of the cost of every data has even reduced a lot. If you know that, like, in 1950s it was $100 trillion to buy 1 TB, and now you know it is just like $100. It has reduced a lot by means of low cost computing and big cloud analytics, data, and mobile technologies. Physical things can share and collect data with like minimal human intervention. So that was the reason these technologies are enabling IoT in a very high extent. So we have connectivity, we have like a multiple host of protocols that could connect easily these things for data transfer. And then who came inside? Machine learning. So when machine learning came inside, the analytics of these data, vast amounts of data, which was stored in the cloud, stored in local, these kind of analytics were made much more easy. And then natural language processing, like you just talk to some personal assistants, and then they have some kind of artificial intelligence for us to provide some input. They take that input and give us proper data output. So these are the technologies that have enabled and taken IoT to a much more better extent. So let's go from IoT to IOMT right now. So there is a college called New England College who gave an idea about IOMT. They were the first ones to talk about this. So IOMT is consists of wearable technologies. Sensors enable hospitals, infusion pumps, medication tracking systems. All these things, they can be used for like monitoring a patient to inventory tracking. They can be used in multiple scales. For example, you may have smart watches right now that will be monitoring your heart rates, your movements. Similarly, there can also be like contact lenses that are used to read the glucose levels, biometric stamps, and the wearer's vitals, and so on. So wearables these days, because of the low cost sensors, have tremendously changed the domain of IOMT. All these devices, what are they doing? They are generating data in a very high speed stream, and then they are analyzed in real time. Therefore, in the medical domain, it is not only important about timely analysis, but it is also important for the detection of this drift, or I would call it as the imbalance of data. For example, there is someone who is in rehabilitation, and then he wants to suddenly switch to ICU or an emergency operation or something like that. So how we could be able to adapt to that occurrence of this abnormal patient action. So these kind of things have to be analyzed using cutting edge solutions and technologies. So this is the concept and the challenges behind IOMT infrastructure. Let's now go to the idea of the evolution of IOMT. So I would like to take it in a perspective of how historically it was there, and then the network healthcare and how IoT is integrated and what are the current devices. So in a historical perspective, from in this one, I'm talking about 1970s, but in my opinion, this idea of doing telemedicine was invented during 1840s in Civil War. People who were injured in Civil War, the communication about them or the how to treat them was being transmitted using telegraph wires in 1840s. And in 1876, Alexander Graham Bell, who invented telephone, only after like 20 years, telephone was used to diagnose and recommend treatment for children with the respiratory condition, for example. So that was the initial idea of telemedicine. And from then, what happened? We created data. There was possibility of interoperability between different kind of communication. And with internet coming inside, there was a possibility of blooming this. So electronic health came, or e-health came inside that. So they were focusing on healthness, how to make the patients more healthy. And from then we started to move. We were not standing in a place with the phone. We started to move with mobile devices. And so the patient became a partner, as a partner of this therapy. So we became to move. And from then we are moving to digital health and then IOMT. So we have smart devices that is a part of IoT, that you have that wearables and things like that. So it's more personalized medicine. And now we are predicting them. So the predictive analysis of this big data is happening these days. And in 2024, we are in the age of IOMT. So this is a historical perspective. So now let's see what is network healthcare. So when network healthcare of IMT, which I'm speaking, is there, we rely more on these sensory devices around us to detect the anomalies in our health, right? So something towards our heart is happening, the heart rate is going down. So we need something from our wearables. So our medical devices should be used as a form for a diagnosis or prevention by the doctors and these things. So this infrastructure basically collects this data and transmits this information to healthcare providers, or can be stored for service for further processing. Over these years, the idea of IOMT is slowly changing, and we are interacting with our doctors, not just with ourselves. We are interacting with our doctors, and then we are monitoring towards our individual well-being, and we are promoting preventive healthcare as the quality of network. So initially, the quality of network, as you see from like 2G to 6G right now, as the quality of network is slowly increasing, the connected medical devices are also becoming more abundantly available. So with these sensors becoming available and becoming a daily part of our human lives, we are all more interconnected with healthcare and our doctors. So that is the idea of having IoT integration with the with medical things. So this integration into this technology is allowing something called seamless connectivity of continuous data flow between the patients and the healthcare providers, and it is facilitating timely intervention. So they need not be with you all the times. You just need timely intervention at that moment. Furthermore, this IoT integration in IOMT is helping for hospital operations through automated systems and even asset tracking. Also, we could bring in inventory management into this thing. By leveraging all these advanced analytics and machine learning, which take in vast amounts of data to understand what is happening, we'll be able to predict the health trends, and we'll be able to prevent any medical emergency, and we'll be ultimately able to provide efficient and effective health care, also patient care. So let's have a small look into what are the current IOMT devices. I have split the IOMT devices into 6. So the first one would be point of care devices. So these are a broad array of diagnostic tools which are aimed at providing or producing results outside the laboratory. So it can be something like a doctor's office or at a home to analyze something like blood, saliva, skins, cells, specimens, whatever. And then smart pills. Smart pills would be something like smart drugs or digital pills. So they are like ingestible sensors. So these smart pills can come in an array of functions, like it can be used for monitoring local pH, temperature, blood pressure, and things like that. They can also be, it was very interesting for me that they can also be used to deliver drugs to a targeted area inside the body. And the next one would be like PERS, or personal emergency response systems. So these are medical alert systems. So they are medical devices that will be used for call for help, like an SOS at an emergency event whenever you press a button. So it is for elderly people. And then clinical scale wearables. So the clinical scale wearables and the consumer scale wearables are a little bit different. So the clinical scale wearables have to be supported or like approved by a regulatory health authority. In case of consumer scale wearable, it is not needed. It's like the watches that you wear, like for personal wellness, fitness, and things like that. In case of clinical awareness, it has to be like approved by FDA, for example, like Food and Drug Administration and things like so. So these devices are like commonly used in like clinics following the prescription of a specific physician. In case of consumer scale wearables, this is not the case. It can be like gadgets that can be used for health applications, which need not have any regulations. And finally, it's like in hospital and monitors that is more in line with like fixed. It is not movable. It is there in the hospitals for like terminally ill patients and things like that. So these are the existing current IoMT devices. Now let's go into the usage of data, how data is being used, analyzed, and so on. So before going into the usage of data, I want to just give a quote of Charles Babbage. So the errors using inadequate data are much less than those using no data at all. So Charles Babbage is like almost 100 years apart, but still he understood the need for data, and even how a data is so small, we need it, and we need to know what we can develop from it. So that is something which is of much importance these days. I'm going to give a small example at the end of this specific section to get an idea of more idea into this quote. Let's go into data generation, right? So IoMT, the Internet of Medical Things, this facilitates continuous generation and collection of medical data, right? So what is this medical data? This medical data can be things like heart rate, glucose levels, blood pressure, things like that. So these IoMT devices, these are transmitting this data wirelessly to something like a cloud-based platform, or it can be a local-based storage where it is aggregated and then it is analyzed using advanced machine learning or AI algorithms. This continuous data stream will be providing valuable insights, right, into the early detection of health issues. So these days, if you see, you can see people wearing a small dot in their hand, which is kind of injected always into their body, and it gives the trend of their glucose, like seeing like, oh, your sugar level is rising, maybe you should take insulin right now. Your sugar level is very much reduced, maybe you should take a sweet right now. So these kind of health trends and detections are possible these days. So these are used to treat chronic diseases, and also providing personalized treatment plans. Furthermore, we should also look into the idea of security and privacy, because we are using encryption and robust authentication mechanisms to ensure security and privacy of this medical data. And by enabling real-time and data-driven solutions, IoMT will not only be enhancing the patient care, it will also be empowering the patient to take a proactive role in managing their health. They are not like just in the old days, it's not like just going, sitting into the doctor and saying what the doctor says and just go home. It is like patient understanding their health and then taking their own decisions so that their health can get better. So that's how data generation is helping these days. Now, data generation is one side. So IoMT is always generating data, fine. And now we should know how you are analyzing that data. So analyzation of data always is into these 4 steps. Always it has been generally, not in just IoMT, in basic IoT, in basic communication everywhere. Descriptive, diagnostic, predictive, and prescriptive. So in case of descriptive analysis of IoMT, it is summarizing and visualizing a historical data from interconnecting medical devices to understand the patient's health trends. How is this patient's health going on? So to get a descriptive idea. And then goes diagnostic. When you go to diagnostic, it's RCA. Always diagnostic is RCA. It is the root cause analysis to know why did this anomaly happen? Why this happened based upon this patient record. And it will be helping the healthcare provider to understand certain events that occurred. Then predictive. So the predictive is much more recent. I will say much more recent because it is based upon statistical model, machine learning, to have a forecast of the future health events. What would happen based upon the current trends and so on. And finally, prescriptive. Prescriptive is basically the automation. So all these data analysis, everything is happened. Once it has happened, what is the future action to do? Or should I inject an insulin to a patient? Or based upon the current data, what is my goal? What is my definition? So these advanced algorithms are helping to take the definitions to the next level. So that is the idea of data analytics. Now I'm going to show you a small example on how this basically works. So this is one of the examples of my supervisor. His name is Anis Kuba from Saudi Arabia. So what he did was he trained the data set of human lungs to know whether COVID exists in a human being or not. So what he did was he trained a CNN, or a convolution neural network, with images of human lungs with COVID. And then he was able to find through the confusion matrix that only 10 out of 600 COVID-19 images are involved in the normal case, that is giving the false negative. And 7 out of 400 images gave non-COVID, that is false positive. So it is not perfect. How can we make perfect? Data. Data is king. So by providing more data, we will be able to reduce this confusion matrix to a much more efficient level. So during the COVID time, if you remember, we were struggling a lot to know whether a person had COVID or not. Technology like this, with enough amount of data, would have been much more helpful. Okay, so we saw things about data analysis and how data is being processed and things like that. So now let us see what are the benefits of having IOMT. So IOMT is done through patient-centric, seamless monitoring and predictive analysis, as I told you before. Bernard Tyson from Kaiser Permanente, we lost him recently. He's a brilliant healthcare mogul. He told this line: "We are entering into an era where technology and connectivity are fundamentally changing the way we think about health and wellness, offering new possibilities for patient-centered care." So when I was reading this, I was so much amused by this word, that patient-centered care. Are we really doing that these days? So what is patient-centered care? Is the integration of IOMT. This helps in streamlining the patient handoff. So the patient is handed off from department to department. So is this timely transfer happening? Is there any risk of errors? How are we improving the continuity of care and things like that? So these are the idea behind patient transfer. So there is data sharing between it, and we are ensuring that the vital information is not lost and the patient is receiving consistent care across different departments of the facility. So that is the idea of patient-centric care. Also, IOMT automation, it can address privacy concerns more efficiently by encrypting the data transmission and robust access to safeguard the patient information. And it also has to have several compliance to regulations and so on. By reducing manual interventions, right? So if we don't have manual intervention saying like, okay, this patient goes to this ward or that ward, or is this patient well, we don't have any idea. So if you are reducing the manual intervention and enabling real-time data update and automated process within the IOMT, we will be enhancing the patient safety, and we will be optimizing the healthcare workflows, leading to overall outcomes. So that is the idea of patient-centric monitoring. So when patient-centric monitoring is a thing, we should also think about seamless monitoring. Seamless, the word seamless means it doesn't have a seam, so it is always continuous. So it's providing continuous real-time tracking of health parameters through interconnected medical devices. And this allows the healthcare providers to monitor the patients remotely, and it helps them to provide critical data like heart rate, blood pressure, glucose levels, all these things, without the need of in-person visit. So avoiding frequent visit from an outer agent, but at the same time having timely intervention when the event occurs. So if there is a timely likelihood of having some kind of a medical emergency, how kind of intervention could be happening here? So monitoring and monitoring and seamless monitoring and the previous one, patient-centered monitoring, are towards data collection. And the next level of this part is prediction. So how are we going to predict based on all these data we have? So we have a vast amount of data collected through these IOMT devices, and then they are analyzed efficiently, and then we are using some kind of algorithms, and we are predicting health trends and potential issues. Okay, so the impact would be like these insights would be able to prevent certain measures, or it could be optimizing treatment plans, and we'll also be even able to improve resource allocation in healthcare systems. So that is the idea of predictive analysis. Okay, now let's go into the big topic, machine learning in IOMT. So I was talking with my mother when I was saying I want to do this presentation. And then my mother, and I was asking, do you have any quote for that? My mother is a Tamil teacher. So she gave this quote, diagnose the illness, trace its cause, and seek proper remedy and apply it with skill. It is not her own quote, but it is from this Tirukkural. நோய் நாடி நோய் முதல் நாடி அது தணிக்கும் வாய் நாடி வாய்ப்பச் செயல். So told by Thiruvalluvar. So why I gave this thing here is I just want you to take your doctor's doorstep. Okay. So this blue image is the doctor's doorstep. Basically, you go to a doctor, you register there, you wait there for hours and hours, basically. And then doctor comes to you, he consults you, he gives you a prescription, payment is done, and he gives a medication. So that is how things are done. But then there are issues, right? So you don't know which department to go. Unless it is a very general doctor, if you go to a big hospital, the problem is you don't know where to go. And then you don't know what medical records you have. What is the patient's history? You don't know. You don't know whether you have to trust that doctor. Is that doctor really a good doctor? He's not even giving me antibiotics. He's a bad doctor, right? Many people in India say that. And then it is difficult to know whether the patient has some allergy, or it is even difficult to track when the patient leaves the hospital. So this idea was formulated by the Ministry of Foreign Affairs in Denmark. So they told we need to have AI. So what AI could do here is to have an electronic medical record, and have something like a service robot to just give, like, check the temperature of a patient. It doesn't need a human intervention. To have service robots, also to have medical imaging diagnosis, and so have virtual assistants for the patients to say, like, okay, I have this problem, this problem, this problem, and then the virtual assistant would help based on the data it already has. So this is the idea of having AI at the doctor's doorstep. It is not just used in a doctor's scenario, it is also used in a drug development, for example. Natural language processing is used for, like, target discovery, compound synthesis, and things like that. We have the image recognition so to know what kind of compound we need to screen, what is the kind of structure of these compounds, and things like what is the toxicity. These are all these days done by image recognition and machine learning techniques. And not only that, we are also going to deep learning to have an idea about, like, what would be how the clinical trial would be. So by running the training algorithms, we have much more idea, like, how it is done, what would be the drug positioning, and so on. So we are slowly moving into the idea of AI in even drug development. So in this section, I would like to give some basic idea of 4 machine learning techniques. The first machine learning technique I'm going to talk about is CNN. CNN, or the convolutional neural networks, is a specialized type of deep learning model which is used to analyze visual data. Okay, it is designed to automatically and adaptively learn spatial hierarchies or features in multiple layers. So as you could see here, I'm going to point my laser. So as you could see here, it goes through so you take a basic image, it goes through multiple layers, and then it would be used for classifying the data. So it goes through things like pooling, it goes flattening that image, and you'll be fully connected, and so on. So for example, a fully connected layer, which is like the end of the network, will be integrating all the features. So all the features which are like removed or separated or segmented here will be joined together in order to get an idea. So CNN is widely used for various applications like medical imaging. Even in autonomous driving, it is highly used. So let's have an idea like how CNN is used in a medical system. For example, an image taken as an input, and then it is going through the segmentation process. And the segmentation process is nothing but the clustering of the parts of image that relate to the same object class. So saying, like, you send a set of images of cats and dogs, and you just say what are cats and what's are dogs. Or in case of image of medical, saying, like, these are COVID images and these are non-COVID images, for example. So this is a pixel level classification, and then the feature extraction process happens, and it converts the raw to a noisy data. And this feature selection process is done based on CNN. So then it's finally what happens is this data is being classified by CNN. So you can see that the feature is extracted and then it is classified. So if the learning criteria saying that, okay, this image is right, is met, it goes to the cloud storage. If not, it goes to classification again. So this is a basic example of CNN. And in this one, we are using the idea of ambient assisted living. So whatever is stored in the cloud data storage is again imported to the imported for prediction in machine learning to check whether it is ambient assisted living, and if it is yes, you are finding ambient assisted living or not. So this was used for image classification using CNN. Similarly, RNN. RNN is an artificial neural network that is used for sequential data. So that CNN is for image data. This is for sequential data, like time series data and things like that. So RNN has connections of like directed cycles. As you could see, they are having a lot of directed cycles, and these connections allow them to have a memory of previous input. So whatever input you have, like historical data where you provide inside, it has a previous input, and this input is provided as loops through the networks. So variants of RNN, there are many variants of RNN like LSTM, gated recurrent neural networks, and things like that. So as you could see here, this is an example of RNN in event detection. So this is RNN and CNN system that is used for low blood glucose detection in a 5-minute window scheme. So what happens here is the individual heartbeats are isolated, then they are grouped into 5-minute segments. Each considered 5-minute segments are chosen if it contains at least 200 heartbeats. So it just verifies every 5 minutes, does it have 200 heartbeats? So if this condition is implying that the glucose event, okay, it should also last for at least 5 minutes. Thus, each 5 minutes ECG segment was associated with a single label. So it's saying whether it is a low glucose or it is a normal glucose. So they were doing this kind of outputs using RNN. And this is SNN, which I really love actually, because it is much more into biomedical systems. They are artificial neural networks that closely mimics the biological brains. They incorporate the concept of time into the operating model. Unlike the other neural networks that I talked before, this is kind of different because let's talk a little bit biology. I want to flex my biology here. So the things like you have like dendrites, which are the end points of a neuron, and then you have the axon, right? So the dendrites receive the input from the other neurons and integrate these signals to influence the neuron's membrane potential. Once this potential is like arrived, okay, I'm at the threshold, a spike is generated. So once it is that, there will be a spike basically. Okay, so this will be transmitted to the other neurons. So this event-based communication makes spiking neural networks highly efficient for processing spatio-temporal patterns, that is space and time patterns, much more efficiently. Okay, let's see a small example right now. This is used to detect respiration pattern. For example, you have an input data. These SNNs, the study here basically is used for like extracting the information such as like frequency and duration of every respiration pattern from entire breathing data set. So whenever the breathing changes, there will be a spike. And based upon that, you get a retrieved pattern. So this is another idea of machine learning. And then reinforcement learning, or else popularly called as deep learning. So reinforcement learning is a kind of machine learning in which you have an agent, and then this agent basically takes an action, okay? And this action is given to the environment. So the environment has a set of states and actions. And now the environment has a state. And if the state is good or not is the observation. If the state is good, the agent always takes the action. And the reward is good. Okay, the action is good. I really like this action, and goes on. That is your policy. Okay. When the action is bad, the reward gets reduced. So once the reward gets reduced, the observation goes, okay, the reward gets reduced, so we have to change the action. So the agent basically changes the action and then provides to the environment so that a good action or an optimal action is always taken. So there are many methods here like Q learning, deep Q learning, DDPG, things like that. So these are widely used in robotics, game playing, autonomous systems, even in medical systems these days. So for example, this one is like a smart medical plan or intelligent system used using deep learning. So this is used for a person with low cognitive ability. So the system utilizes customized reminders and alerts to help the patient to adhere to their medication schedules to avoid any errors. The core of the solution is to have a multi-agent deep learning, deep reinforcement learning system. And this system, what it does is it balances the exploration and the exploitation and optimizes the assistance provided to the patient. For example, it suggests a drug and the patient, whether he takes a right box or a wrong box, and then the checker verifies it. So verifies it and it changes the policy. So this is basically a reward mechanism here, and it helps in improving the efficacy of the home treatment of the patient. So we saw a set of machine learning techniques that were used in implementing IOMT. And now let's go into some use cases. So the first use case I want to talk about is implanted sensors. So in the beginning of this presentation, I was talking about like ingestible sensors. So something which you could eat and just go to your body. So this is the same thing. So they are miniature devices that can be, for example, even surgically embedded into the human body, and it continuously monitors various physiological activities such as heart rate, glucose level, and things like that. So this is and then this could be passed to a physician for him to provide some possible output and things like that. And then smart pill dispenser. Smart pill dispenser in the sense, like, I've seen a lot of patients even in India who take around like 15 pills a day, for example, for health. And the thing is, it is not safe always, because no one needs 15 pills consistently. The doctor must be able to change it whenever he can, based upon the output of the patient, so that the patient may live more healthily. So there was this idea of a smart pill dispenser where there is you provide all the pills to this dispenser, and then the pills are given based upon the condition of the patient. And this is directly controlled using an app with the healthcare provider. So the healthcare provider can see what are you doing. And this can also be used for enforcing the patient to eat tablets. For example, if you see people with tuberculosis, they are supposed to take pills like 7 to 8 pills a day, and then they don't take it because these people don't like to take pills. So there are cameras there which can capture the instance of the patient taking the medication, so that the patient need not go to the hospital to take it, but he can just sit in the luxury of his home and take his pills. So smart pill dispenser is another one. And we are moving into the idea of like connected imaging. So we are having like MRI, CT, X-ray machines, and they are much more connected to enhance the diagnostic process of the patient. So these connected devices automatically transmit the imaging data to the cloud platform or healthcare provider and so on. And these AI or algorithms that we have can analyze these images and assist in identifying any abnormalities. So this is a radiology in which you could see that the bone abnormalities can be directly seen, and this can be done in more real time. So this can facilitate to more remote consultations, and second opinions also would be possible with multiple doctors seeing the bones and things like that. And these images, which are shared more securely and with the diagnostic data from all these specialists, we will be able to enhance the patient outcomes. So that is the idea of connected imaging. Finally, I would like to talk about intrusive imaging. So intrusive images, getting inside the body to get images. So this is an example of IOMT-enabled advanced endoscopic devices with network connectivity. They help in providing more diagnostic and therapeutic procedures. So what you see here is smart endoscopes capturing high-definition images of videos of internal organs. They are not, so you are going inside, and they are much more minimal invasive procedures. And AI algorithms here will be able to assist any abnormalities like tumors, polyps, and things like that. And they'll be we can have something like a longitudinal study. So to have an idea like what at this point of time, what kind of tumor the patient had, and the next T0, T1, T2, what happened. So we'll be having a longitudinal study and enhancing the patient records and also the evident treatment planning. So this is the idea of intrusive imaging. Okay, so we are coming to the last section of our presentation. So we saw all the things like how imaging is done in the application level layer and things like that. But the communication level layer is also much more important. In this one, there are several. For example, even Wi-Fi, 5G, 4G, everything can be used basically for communicating, but not actually, because they have to be much more regulated. So that was the reason W-band or wireless body area networks was initially developed. And then there are novel techniques like VLC, which I would discuss much more in this section. W-band or IEEE 802.15.6 is standard for providing wireless communication within the surrounding body. So it supports short-range wireless communication in the vicinity or even inside the body. So that is the idea. So these communication work on the ISM or the industrial scientific medical band, which are the bands supported by the national medical or regulatory authorities. So they provide extremely low power data and data rates up to 10 megabits per second, if I'm right. So they have to follow very strict guidelines for this, and these standards will have effects on always considers the effects on portable antennas. Like if we have something like a mobile phone, it does not affect it, and it also looks into the radiation pattern to minimize any specific absorption rate or SAR into the human body. So these are something which is much more focused towards the wireless body area networks. So what I provide here is the MAC structure of it. So as you could see here, it provides the frame control. It says what is the sender ID, what is the body area network ID, and things like it's much more secure when compared to other networks. But then it also has vulnerabilities and also possible trade-offs. So those are things which we have to more consider when we look into this kind of networks. And then visible light communication. So visible light communication has been there for many decades, but it was but we did not have enough technology during that time to enable it. But these days, IEEE 802.15.7, that is 15.6, this is 15.7. So this defines the physical and the MAC layer for light-based communication. So unlike others which use radio waves, this considers light for communication. This is designed for short-range optical wireless communication, and it has potential for several applications like underwater communication, vehicle-to-vehicle communication, so on. This standard has multiple data rates. Even it supports terahertz level frequencies. And the thing is like these depend upon the environmental conditions. So that is the biggest challenge in visible light communication. With the collaboration with SRM Ramapuram, I published a survey recently in which we discussed things towards VLC indoor localization. So VLC indoor localization, in the sense, it is a fundamental capability of mobile devices which you have to be connected through indoor. So you have lights which will be acting as like transmitters. So they can help in determining the real-time position of patients. For example, there is a patient and you have lights. You can have the lights to see where this patient is going, basically. One of the major advantages of indoor localization of VLC is it's completely non-intrusive, and they could be enabled by existing lighting infrastructure directly. So in this one, as I see, we see a medical person who is moving along an indoor environment, and we could also think about having like asset management and hospital equipments using this kind of methods. And then the another one would be like patient monitoring. It's more similar to the other one, but the thing is like here the data is transmitted from the patient to something like a base station through a external medical database. At the same time, it's also can be passed to a medical professional. It is much more secure. And as you can see in the figure, you can see that this lights, which are LED lamps, are like transmitters. They can transmit the data to all these external entities. And visible light communication is much more secure when compared to the RF, because they cannot be hacked as much as the RF level. Okay, my presentation is almost over. Let's talk to some discussion points at the final point. First thing, how do I improve security? Always, this is the biggest question anyone should ask. So the vast amount of sensitive health data that we are providing or transmitting over IoMT networks, it is always susceptible to breaches, right? So what kind of healthcare providers or device manufacturer, what kind of encryption, robust encryption or compliance they can provide? So this is a question we have to ask when we look into IoMT. Then interoperability. So we have multiple devices. So when you have multiple devices, they are governed by multiple protocols and multiple standards. So how to make a seamless integration here and make it not difficult, so everything works along with each other? And what would be the best strategy for developing something like a universal standard, whether it would be even possible? That is a big question that we have to ask. Also infrastructure, right? Infrastructures in the sense like how to make this internet connectivity much more reliable. These days it is not reliable. Currently it is in paper, it is much more theoretical, but it is not much more reliable. And how to have this kind of stuff in a remote place. So if you're living in a complete remote place and you want to have these kind of healthcare solutions, how to do that? So that is a big question we have to ask about our rural and low resource in my environments. And then reliability and accuracy. Reliability and accuracy both are much more vital and crucial in IoMT devices. So how can manufacturers ensure that the consistent performance of these IoMT devices is possible? So if you have a watch in your hand that tracks your heart rate, for example, you cannot rely on it today to say this is the exact heart rate and I am going to believe that. No, you cannot do that, right? So how can manufacturers ensure the consistent and the accurate performance of these devices? Then what are the trade-offs of IoMT? So when you have things like security, then you have to have trade-offs. So if you look into some data like ECG, if it is even 5 milliseconds later, it is not valid. So how to have trade-offs, how to save the trade-offs, how to have some protocols to do with like trading of energy efficiency, latency, security, and things like that. So how quality of service can be eventually maintained. So that is a very big challenge to look into. And then this is the ultimate challenge that we have. I just gave the word choosing of ML technique. I should also add another one thing. Why ML technique? So why we are going for machine learning? Whether machine learning is really needed for this or just traditional methods are okay for that. So we should ask that big question. And also we should ask, if you need machine learning, some kind of learning is needed, then we should ask what kind of machine learning technique is used and what kind of learning should we do? From this learning, what are we improving, or whether are we fast in prediction? So these are the questions we should always look as challenges in IoMT. So finally, I want to finish my presentation with this quote from Eric Topol. He said that the future of medicine is in understanding the complex interplay of connected devices, genomics, and artificial intelligence for providing a personalized and proactive care. So that is the idea or the realm of medical devices that we are slowly going into. Thank you for the presentation. Thank you.
Thank you, sir. Participants, you can ask your queries now. Participants, you can ask your queries.
Good evening, sir. Which technique is best for processing medical images, sir?
Currently, I think it would be CNN. CNN is usually used for medical images, but still it is not very efficient in terms of processing, I would say. So how about we think about some combinatorial technique like using CNN and LSTM, so that we'll have a historical data idea and also having CNN for segmentation and things like that. So that's how we are slowly going into.
Thank you, sir.
Any other queries?
Sir, good evening. This is Dr. Bhanupriya from SRM. First of all, I would like to appreciate the presentation. The slide has taken, I think you have taken immense effort to make the slides. It's very good, sir.
Thank you.
My question is, so what is the effectiveness of current IOMT solutions in rural healthcare settings, sir?
Okay, that's a wonderful question, actually. So the thing is, like, it is not very much effective because IOMT, in the sense, like, it is just, if it is just medical things, or if it is offline, it can be effective. But then when you have connection involved in it, it is going to be a big challenge. So I would just like to tell some small example. Even in vehicles, for example, when you have vehicles which are connected through internet, when you go to rural areas, you will not be able to connect. By that, what happens is, like, you cannot even enter into your vehicle, right? So this happens. So think about medical images that are completely relying on internet services. So that would be really tough. So how to mitigate it? So how to mitigate it is like by having edge processing. So you have edge processing, that is like local processing. So you have like medical data, and then it is, for example, it is much more crucial. So if it is much more crucial, we should have local processing of that data. We should not completely rely on internet processing there. And we are slowly moving towards it, like having like global internet and strong connections everywhere. Maybe we could improve. Maybe it's a big maybe, but we are there. Eventually, in a decade or two, we'll be able to do it. Hope that
Okay,
answers
sir.
it.
Sir, one more question.
Yes.
The strategy for this healthcare organization transition from a traditional to a modern IOMT based systems. So what steps should be taken to ensure smooth and secure implementation, sir?
Okay. Uh, to ensure a smooth transition, I would say that adoption of techniques. So that is the biggest thing we have to do. The one thing people are so afraid is adopting new techniques. So we have to have adoption of new techniques into existing healthcare systems, like diagnosis and things like that. But it would be much more challenging because the current ML strategies that we have are not much more effective in terms of prediction and so on. So we have to improve our strategy as like academicians, as we are. We have to provide more input data to improve the predictive capabilities of ML. We have to improve ML by have combinatorial capabilities of machine learning techniques. And by doing that, we can say, like, okay, if there is something like seizure detection, we can do it in terms of like 5 milliseconds. And then we are providing a technology to the doctors. And then adoption of that technique takes time. And eventually it will be, there will be a smooth transition, as you say.
Okay, sir. Thank you, sir.
So one of the
Good evening,
participants-
sir.
Good evening.
This is Padma Kumari from Shastra University.
Good evening.
I have a basic question over data sets, sir. Being these are deals with the medical data set, approaching about the real-time data set is very difficult now, sir. Can you suggest some of the any other website or anything apart from Google to get some medical data set for our research work? Being an academician, we cannot approach. I mean, it is very difficult to approach for getting the data set. So, how can we proceed with that, sir?
Actually, it is a very big problem that we ourselves are facing in each and every single day. These days, what I'm doing is like I'm creating synthetic data sets myself to train my systems, but then it is not very true. So the thing is, like, only way is to get much more relationships with these organizations who are able to create these real-time data sets in order to develop or machine learning algorithms. So that is the only thing to do. This is a very complicated question, to be honest with you, because the thing is, like, we should have relationship with the hospitals, with like these funding these organizations who are like much more related with these medical data sets. So that is the only way. We don't have any specific way to do it.
Thank you, sir. Thank you very much.
Sir, please share your mail ID here, sir.
Yeah, sure, I'll share. But also, I would like to say that we have a PhD call going on in my institute. So if anyone is interested, please, I would like to share with your students and so on. So I'll share both of that here.
We will contact the organizers.
Sure.
They are having, I think so.
I am. I'm sending the link in the comment.
Hi,
Also,
sir. Sir, 1 second.
Yeah,
I have a doubt.
yeah, please.
I'm planning to do the PhD in future, sir.
Mm-hmm.
Which field is the very most effective and then wanted? Which area? Whether the image processing or any other
Okay.
thing. Actually,
It's
project is based on image processing.
okay.
Due to my personal commitment, I took some break.
Mm-hmm.
So I'm planning to do PhD, but I don't have much idea about it.
So it is where your passion lies. So wherever your passion lies, just go there and do the PhD. That's what you have to do.
Actually, image
And
processing. I did my
it's good.
ME project.
It is good. Image processing is really good these days, and artificial. So the things like image fusion is a good thing which is going on these days, and artificial intelligence for predicting using fused images is a big thing these days. So it's about like fusing multiple images like MRI, CT, and things like that, and having artificial intelligence to predict what kind of anomalies or things over there is there. So that is a big field over these days.
Okay, MATLAB or Python, which is the most
Python.
effective? Python.
Yep.
Python is the most effective and accuracy oriented. Huh?
Yep. Because you're working with more machine learning techniques.
I don't
so
have any idea about Python.
you have to learn.
What I'm asking now, MATLAB or Python, which one is the most effective and then
Python.
accuracy based?
Python. Yeah.
Okay.
MATLAB
Okay.
has its own accuracies and things like that. But then when you're coming into machine learning, the much more training of data and all these things are much supported using PyTorch, TensorFlow, and things like that these days. So you have to go into Python eventually.
Okay. Okay. Thank you. Thank you so much, sir. Your presentation was very good.
Thank you.
Thank you.
Any other queries? So participants name Samuel has posted a question stating you to suggest a research area on Internet of Medical Things.
So research area on Internet of Medical Things, I would like to suggest things on digital twin, for example. If it would, I mean, it is a upcoming research area. It is more novel. Things towards like machine learning techniques, like transfer learning, meta learning. These novel techniques these days are also getting traction. Federated learning, even where you have like multiple servers and you learn from all the things at the same time. So these stuff are getting traction these days. So these are good research areas to look into.
So thank you. Any other queries, participants?
Yes, ma'am. I have queries.
Yeah.
Sir, good evening,
please.
sir.
Good evening.
Sir, I'm Prabhuraj from St. Michael Group of Institution, Sivangai, sir.
I see.
Sir, can you hear me, sir?
Yes. Tell me.
Sir, I have one doubt. What are the difference between the regular things in medical industry and IOMT things in medical industry? ரெண்டுக்கு என்ன வித்தியாசம் கேக்குறேன் சார்.
What do you mean by regular things?
Regular things means பேஷண்ட்ஸ் டாக்டர்ஸ் மீட் பண்ணி டைரக்டா அவங்ககிட்ட போய் பேசுறதுக்கும் இந்த ஐஓஎம்டிக்கு உள்ள வித்தியாசம் என்ன சார்? பேஷண்ட்டுக்கும் டாக்டருக்கும் ஒரு கான்டாக்ட் இல்லாத அளவுக்கு இருக்குமா சார்?
Yeah. So we are slowly moving towards that. So I don't know if you know about this news from China. They developed a hospital recently that could treat 4,000 patients a day. So with the population of the world increasing, it is much more tough to have this doctor-patient thing going on these days. So also doctor-patient relationship, it's kind of getting different. We have to have these medical records. We have to have these patient records, for example, like allergy of the patient. And
Yes.
I was talking about this idea of longitudinal lookout. So having a longitudinal idea. So what was the start of the disease? How did the disease go? What medicines were given to him? What was the improvement? And all these things, so this can be only done through the processing of this medical data through IOMT. So I'm not saying that doctors should be completely expelled or something like that. Doctors should be there, and this kind of IOMT technology will enable doctors to do better. So that is the idea.
Oh, yes,
Okay,
sir. Yes, sir. Okay, sir. Okay, sir. Okay. Thank you, sir.
yeah.
Any other queries? Participants, any other queries? My sincere thanks for your exceptional presentation, sir, at this event. Your insights and expertise about Internet of Medical Things, imaging strategies, and visual light communication has made a significant impact, and we are grateful for your valuable contribution. I thank you once again for sharing your knowledge with us. Thank you, sir.
Thank you so much.
Ma'am? Priya ma'am?
Hello. Hello. Hello.